Okay, the final concept we're going to talk about in regards to universal law of gravitation is orbits. So an orbit is when one object orbits around another object, similar to how the Earth orbits the Earth. So we're specifically going to talk about a satellite orbiting Earth. So we have a 700 kilogram satellite. Is placed in orbit at a height of 800 kilometers above the surface of Earth. We want to find A, the velocity of the satellite, and B, the period of the satellite. And remember, period of something is just the time for one revolution, okay? Or one oscillation, or one anything. Okay, so we're going to find the time for one revolution. So let's draw a picture first. So we have Earth, and we have the satellite, which is rotating around Earth. Obviously, my picture is not to scale. We're going to say that's a perfect circle. Okay, we know that the radius of, basically we have a circular motion problem, and we know that the radius of Earth is 6.38 times 10 to the 6 meters. And the satellite is a distance of 800 kilometers above, which is equivalent to 800,000 meters above. So when we want the radius of the whole circle that the satellite orbits, it's going to be 800,000 meters plus 6.38 times 10 to the 6th. So you get 8 times 10 to the 5th plus, so radius total is going to equal the radius of Earth plus the distance it is above, which is 8 times 10 to the 5th. And you get 7.18 times 10 to the 6 meters. Okay? Something else you need to know is the mass of Earth, which I told you in the last problem was 5.98 times 10 to the 24 kilograms. If you ever need to know the mass of a planet, just make sure you look it up if you're not given it. So for part A, we know that the sum of the forces is equal to this gravitational force that the satellite feels toward Earth. So that is the centripetal force that is keeping this satellite in orbit around Earth. It is Fg. Okay, so the sum of the forces is Fg, which equals mass times acceleration centripetal, since it is in a circle. So we get G m Earth m satellite divided by r squared equals m satellite, because we're specifically talking about the satellite doing the orbiting. It's the one moving in the circle. V squared over r. Okay, one of our r's are going to end up canceling, and we want to solve for v. So m cancels as well. We get the square root of gm over r. So v equals the square root of g m of Earth over r. Okay, let's go ahead and plug those values in. G is 6.67 times 10 to the negative 11. Mass of Earth, 5.98 times 10 to the 24 kilograms. And our radius was, we already found it, 7.18 times 10 to the 6th meters. Okay, go ahead and pause the video and take a moment to plug that in your calculator on your own and check your final answer. You should get 7,447 meters per second for the velocity of the satellite around Earth. Okay, for part B, we need to find the periods, the time that the satellite goes around one time around the Earth. Well, we know velocity is equal to distance over time. And we also know that the distance this satellite travels around the Earth is going to equal 2 pi times the circular path's radius divided by time. So if we want to go ahead and solve for time, we multiply t on both sides. Let's just ignore this one in the middle. And divide by v. You get t is equal to 2 pi r over v. If we plug in our givens, we get 2 pi times 7.18 times 10 to the 6th divided by 7,447 meters per second. Okay, let's just check our units really quick. That was meters per second. We're left with one 1 divided by 1 over seconds, which is seconds. Okay, so go ahead and plug this into your calculator. You should get 6,067 seconds. Okay, so the typical question is, what is the period of a satellite that's in orbit around Earth in terms of hours? So let's take our 6,067 seconds and convert it to hours. So go ahead and pause the video and do that on your own, then check your work. So there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So let's check our dimensional analysis. Our seconds cancel, top and bottom, minutes cancel. We're left with hours on top, which is perfect. So when we multiply this together, 6,067 divided by 3,600, we get 1.86 hours. Okay, at this point in time, you can go ahead and work on the universal law of gravitation homework.